Hello everyone, my name is Fanjing Zeng from National Yangming Jiaotong University. I'm presenting our paper about cross-device notification interactions. When we receive a notification for a new email, we may first fill it on our smartwatch through vibration. As the email may be lengthy, we might switch to using our smartphone to read its contents. And for further actions such as replying, we may use our computers. In this example, you could see that we interact with various devices that were both smartphones and computers. These days, a lot of us have more than one device, and each device has unique features that make them suitable for certain tasks. For instance, wearable devices and smartphones are portable and great for receiving notifications on the go, but may not be ideal for browsing files or typing responses. In contrast, computers and tablets have larger screens, making them great for viewing content. Besides, computers have better input capabilities, and tablets are good for writing or drawing, but they are less portable. Therefore, we can select the device that we deem most appropriate for interacting with notifications based on its features and our preferences. However, if a user's preferred device for interacting with notifications is not available in the appropriate context, such as when the screen is not visible or when the device is not reachable, they may either postpone the interaction until they can access the ideal device or use an alternative device instead. To understand more about how frequently and why discrepancies between ideal and actual device usage occur, as well as potential solutions to this issue, we would like to ask the following questions. What are multi-device users' ideal and actual usage of devices in notification interaction stages? How does the ideal usage of devices change depending on the device context? What causes users to deviate from their ideal device usage, and when does this happen? Do gaps between ideal and actual usage relate to device context? We conducted an ESM study with multi-device users. Participants were asked about their actual and ideal usage of devices for performing each of the notification interaction stages, and the questions relate to context. They were also invited to participate in optional post-study interviews. In those interviews, we mainly focused on 1. How and why they switch devices across the notification interaction stages, 2. How device contexts affected their device choices, and 3. The reasons behind the gaps between their actual and ideal usage. Our findings were based on 31 participants who had used at least 3 kinds of devices to receive and interact with notifications, including 12 males and 19 females. After data cleaning, there were around 1,700 ESM responses in our final dataset. In the first part of our findings, we look at participants' ideal usage of devices. For most participants, phones were the most preferred device when it came to interacting with notifications at any stage. Wearable devices were preferred to use to notice alerts and take a quick glance at notifications, while computers were the device of choice for reading the full content and taking further action. Tablets were rarely considered the ideal device. Then we take a look at participants' actual usage of devices. In general, the trends we observed in actual and ideal usage of devices were similar. We found that participants' actual usage of devices was slightly lower than their ideal usage. This difference indicates that there were discrepancies between the devices participants preferred to use and the devices they actually used. We compared the participants' actual and ideal usage of device. We found that when the non-phone device was named as the top preferences, only half of the time they were actually used by the participant. For computers, the gap between actual and ideal usage was particularly apparent when participants wanted to take a glance at notifications. As for wearable devices, gaps were observed during both the stage of glancing at notifications and when reading the full content. We found that the ability to use their preferred device during a specific notification interaction stage was influenced by the device context. The nature of these associations vary depending on the type of device and device context. For example, whether participants could reach and use their computer in the moment was crucial in determining whether it would actually be used as a preferred device for interacting with notifications, regardless of the stage. Similarly, The screen-readable state of the computers was also an important factor to whether people would eventually use them to read and act on notifications. When wearable devices were the preferred option for glancing at notifications, they were more likely to be reachable and usable when they were actually used compared to when they were not used. Finally, we observed that participants were more likely to continue using the same device for subsequent notification interaction stages if they had used or wanted to use that device in the previous stage. Both phones and computers were highly likely to be used again in a subsequent stage if they were already used in the previous stage. When it came to the ideal flow between notification interaction stages, the desire to continue using the same device for subsequent stages became more apparent in the later stages, especially for computers and tablets. To improve the multi-device notification experience in the future, we recommend that the multi-device notification system should be aware of users' device preferences and device context, and deliver notifications accordingly. If the user's preferred device for notification is not in the appropriate context for interacting with it, the notification system should delay the notification until the preferred device becomes available in the appropriate context. Besides, the system should center around individuals rather than devices. While some users may prefer certain devices for specific notification interaction stages, such as using a computer for reading and taking further action, we recommend that future systems allow notifications to be synchronized across devices, giving users the flexibility to choose the most appropriate device for each interaction stage. This synchronization would also help to address the issue of duplicate notifications across devices, as dismissing a notification on one device will remove it from all synchronized devices. However, this approach would also remove notifications that have already been read on other devices, making it difficult to interact with notifications across devices. To address this, we suggest that the system provide options for further actions, such as allowing users to mark notifications as to-do items and address them later on multiple devices. This paper explores how users interact with notifications across multiple devices. We found gaps between how users actually use multiple devices for notification interaction and how they would ideally like to use them, as well as the impact of different device contexts. We also discovered that users tend to stick with the same device for multiple stages of notification interaction. Ultimately, our findings have important implications for the design of a multi-device notification ecosystem in the future. Please refer to our paper if you need more details. Thank you for your patience, and we're open to any questions.